Welcome to Ask and Learn.
All right, guys, we're doing problem 86 of chapter 18 in Chemistry Central Science. So, a reaction that contributes to depletion of ozone in the stratosphere is a direct reaction of oxygen atoms with ozone. So, at 298 Kelvin, the rate constant for this reaction is 4.8 times 10 to the fifth inverse molar times inverse seconds. Based on the units of the rate constant, write the likely rate law for this reaction. So our rate for a reaction is always in molar per second, or you can write it as molar times inverse seconds. So since for our rate constant we have inverse molar, we have to multiply it by molar squared if we want to get the correct rate for our function. As the correct sign for our rate. So we have two reactants here, oxygen atom and ozone. So each is going to be first order so that they can interact, so that their units can cancel out. So we can write the reaction as the rate. I'm just going to denote this R equals K times concentration of O on the concentration of O3. The exponents for each is going to be 1. Now B. Would you expect this reaction to occur via a single elementary process? I would, because if you look at this reaction, we have one oxygen atom reacting with one ozone molecule to create 2 O2. That would be a bimolecular reaction. So I would expect that to occur with a single elementary process. That is a common bimolecular mechanism is a common process. So, and also explain why for C, use delta H values from appendix C to estimate the enthalpy change for this reaction. So we have, remember, delta H of O2, that's going to be 0 because that's an element standard state. So we're against Hess's law, delta H reaction is equal to delta H products minus delta H reactants. So 0 minus 142 plus 247.5. So delta H sorry, 142.3 plus 247.5. Just move this. Minus 389.8 kilojoules per mole. And they want to know, will this increase the temperature of the stratosphere or decrease it? And you can see that the delta H for this reaction, that's negative, so that means it's an exothermic reaction. And exothermic reactions means that you're releasing heat from this reaction, so that means that your temperature is going to increase. So when you have delta H is greater than 0, delta H is less than 0, as Q increases, delta T increases. And when you have delta H is greater than 0, delta T decreases. Or just get rid of delta T. Just put T like a T. So you're going to see an increase in temperature when delta H is less than 0 for an endothermic reaction, for exothermic, and for endothermic reactions where delta H is greater than 0, you're going to see temperature decrease.